Welcome back, YouTube. Today we're going to get into one of the oldest debates known since the pushrod V8 has ever been created. Today we're going to be comparing the 426 Hemi against the Ford Camry engines. Within that comparison, we're going to be comparing the pushrod V8 comparison, as in the 426 Hemi, against the chain drive of the Camry engine. All of that information versus more modern day rubber drive type systems that we are seeing in our newer cars. Now, the reason why I came up with this video basically is because all of the debate that you might see. With modern day vehicles, the EV push to address the efficiency of our vehicles and the dependency, we know that that's going to be affected with the current events within politics. And the simple numbers of our older vehicles being available to take the place of modern day vehicles, they're shrinking. So as a population, not only within the United States, but within the world, we're very limited in what we can get our hands on to continue to keep using the fuel source that we have. Now, I want to add this in here before we dive into the exact things that are going on between the Hemi and the Camry. All engines since the four-stroke design came out with the early edition of the Ford Models A's and so on and so forth, even prior to that, was built around the fuel. So while some individuals are attempting to use other fuel sources, whether it be methanol or nitrometh or propane, you have to remember that these engines were designed around the fuel. It wasn't a combination where somebody put a bunch of mechanical components together saying, oh, we can put this fuel source to it. They looked at what was available as a fuel source and built the engines around that. Now that dictated what the materials of the engine were actually built out of and the timing that it took for the fuel to burn. That goes across the entire performance industry, where maybe some racing syndicates allow high compression race fuels. The engines have to be modified around the fuel source. So when you see these different dyno sessions that are out there, saying, oh, we use pump gas with a little bit of a splash of race fuel. Most of the time that is done for detonation protection, to basically allow the engine to live longer. Now, the reason why detonation occurs because of a couple different things. It occurs obviously from the squeezing of the fuel and air ratio into a small circumference or a small compression ratio, creating heat spots. Now, fuel, gasoline, petroleum fuel, doesn't just provide an energy source or an explosion to push a piston down. It's actually a cooling fuel. So realizing the engines, the original engines created around petroleum fuel, were cast iron. Okay, so with the advancements in today's engines switching more over to the aluminum, we're not extracting as much energy out of every ounce of fuel that is being consumed by the engine, because the engines are running cooler. Now, as I mentioned, some of these individuals are trying to attempt to use propane. All right. It was not designed necessarily around what we are seeing in the automotive performance industry. Propane has a different burn rate and requires a different compression ratio in order to work. Okay. So supplementing an alternative fuel to a platform that you might already have is not going to necessarily extract the most amount of power out of it, because the design of the engine, the power plant, was designed around the fuel. Now, with that, getting into the debate between the pushrod Hemi engine to the Ford Camry engine, there's a reason why some individuals will say if the Ford Camry engine was allowed to get into NASCAR, that it would have dominated. Okay. I do not believe so. And we're going to get into maybe some of the specifics behind it. Now, within research, or basically I created this video because I ran across this article in an older catalog, or magazine, excuse me. Oop. Well, you guys can read that, right? This was an article written by Steve Dulcich from Hot Rod Magazine, or Engine Masters Challenges. It's actually an Engine Masters catalog or magazine from 2013. Now, over the last, over the last 25 years now, the technology of roller cams has been a point of discussion and the top topic when it comes to hydraulic flat tappet failures to all kinds of different things. Okay, so one of the prior statements that I made is that I noticed the failures occurring back all the way to 2001. Since that point, the hydraulic flat tappet cam industry has made some improvements in order to continue to sell the stock that they have in warehouses, and also to replace broken down original equipment. A lot of performance enthusiasts automatically skip over the hydraulic cam design for the alternative option within roller designs. Now, I also, within the last couple of weeks, some of the dyno mule sessions that are being put on, obviously using roller type systems, they've noticed that the RPM range has a defined drop off of when the RPM of the combination is reached and then where the power just drops off like a waterfall over an edge. And also talking about the more modern day solid roller lifter designs. Okay, so again, I'm going to hold this up to you guys. Hopefully you can see this. If you do have the ability to, I doubt this is even on YouTube to be able to find it, but it's a 2013 Engine Masters Challenge article written by Steve Dulcich. I'm missing the cover, so I can't tell you exactly where you can find this in the archives, so on and so forth. But now these lifters are talking about different things as far as the roller designs, whether they're needle bearing or bushed. Bushed rollers. Okay, now that's going to get involved with the discussion that we have today when we're comparing the top basically engines of the muscle car era. Now, some of the things that we're talking about with the 426 Hemi is going to also apply to the Chevy big block. So while I'm mentioning 426 Hemi, it is referring to the push rod engine families. So even with the Cammer engines, the push rod engine of the Ford family would be the 429 Boss. Again, that would categorize itself in the push rod family, leaving the Cammer out during that time and be more related to the more modern chain-driven engines. Now, while the American manufacturers were looking at the additional flow through cylinder heads, they realized that the Hemi spherical combustion chamber allowed more area around the entire valve to allow more air to flow into the cylinder. And the valves are oriented towards the center of the cylinder where the greatest amount of vacuum occurs. So by introducing that air at that angle of a Hemi engine, the air has to flow equally around the valve. So it's exposing the perimeter of the valve, the curtain of the valve, with more equal distribution, and it creates the tumble motion within the combustion chamber as the piston travels up and down the cylinder. Now, the downfall to a Hemi type engine, especially the race variations, they used a dome piston. So even though they used the hemispherical chamber, they put a wedge into the middle of the chamber with the dome of the piston, causing the flame travel to be altered and not necessarily be the most efficient burning combustion chamber. The street variations of the 426 Hemi, had a lower dome. So while the quench areas of the combustion chamber were opened up to allow more of that tumble to occur, it also allowed the fuel distribution to be gathered together in a larger cloud. And then that ignited would not be as efficient and burn as fast as a higher compression type engine. So in the NASCAR variation of the Hemi, with the high dome, ignition happened fairly quickly, but it was not as efficient as some of the other versions. Now the 429 Boss semi-Hemi did basically the exact same thing as what the 426 did, but they altered the valve placement to where it was offset. That's why it's called a semi-Hemi. The exhaust valve is traditionally in line with the actual center of the cylinder, while the intake was favored towards the cylinder wall. Now, anytime the valve gets close to an obstruction, it becomes a hurdle that the air has to go over. Not only the air that's coming in, but also the amount of vacuum that is exposed to the valve face, the face of the valve. There's not as much vacuum on the inside as there is to the outside within the smaller area between the cylinder wall and the valve, causing a restriction. So there is some downfalls to the semi-Hemi. Okay, so even though the semi-Hemi combustion chamber was filled in a little bit more compared to the 426 Hemi, in order to achieve those higher compressions, they didn't need to use a larger dome piston to achieve them. Even more modern day Hemis within the Chrysler engines, the 5.7s up to the 6.4s, instead of using a large dome piston, they've actually filled in the combustion chamber of the Hemi head to achieve that tighter squeeze. Now, even with the more modern day Hemis, by filling in the combustion chamber itself on either side of the valves, it again causes a restriction for the vacuum to be exposed equally around the entire valve until much higher within the lift of the design. So this can be a little bit opinionated, but obviously I don't have a Camry engine sitting here, and I would guarantee that probably 99% of you that are watching this, you've never even had your hands on one or seen one. They're very rare. Now, my opinion, the difference between the 426 Hemi and the Ford is obviously because of the push rod design. What we are noticing with the solid roller designs of today, the push rod engines, when those engines achieve a certain RPM, higher RPM, more of the vibration from the valve train is absorbed into the actual materials of the engine block and within the design of the rollers. Now, going back to the article from Dulcich here, which we'll be getting in a little bit, when you use rollers that have these small needles, the amount of impact that comes on the wheel, the roller of the lifter itself, depending on the camshaft profile, it has a limitation to the actual profile, the aggressiveness, because those roller bearings, being as small as they are, it doesn't take very much to shatter them. So by replacing it with the bushing style rollers, that bushing can withstand a little bit more than the roller bearings. But because they are bushing, they also create more friction. So more resistance to the roller actually moving over the cam profile. If we go back to the 426 Hemi of the mid-1960s during NASCAR and the large winged vehicles, they could withstand 7,500 to 9,000 RPM for the entire race. And there was very little problems occurring within the valve train in engine failure. Typically it was the connecting rod, obviously blown out the side of the block, or a problem with oil starvation is normally what occurred in engines that failed during those times. If you were to take the exact same camera engine and place it into a vehicle and compete against the 426 Hemi, they would easily be able to match the performance level horsepower per horsepower. But the camera engines, because they're chain driven, the vibrations that occur within the valve train are multiplied. Each individual camshaft provides a vibration. So as it is making contact with the rollers and the valve tips, there's multiple frequencies that are going on. And now you double that for the amount of camshafts that are in a camera engine. That vibration is absorbed by the cylinder head to an extent. But again, that vibration would also cause the bearing surfaces of the cam pillars to break down faster, unless they have an absorbent material between them to absorb the shock. So in modern day engines, the oil is that shock absorber. There is no lifter, hydraulic lifter, to absorb the vibration coming from the valve train. Now the pushrod 426 Hemi did use a solid lifter, but again the concussion of the valve train was absorbed with the amount of oil that went through it. Now obviously even back in the mid 1960s or to 1970, the big wing cars equipped with the 426 Hemi in NASCAR, they didn't use rollers. They used the solid flat tappets. So the oil consumption problem was their main concern. How do they supply as much oil as they possibly can to the engine in high banked roadways or speedways, and still keep the adequate oil in the engine to absorb that vibration? Now, within the rotating assembly, obviously the crank vibration dampener would also absorb some of the vibrations that came from the balance of the crank. But also with each individual concussion of ignition that would be transferred into the aluminum piston through the connecting rod into the crank would also be transmitted to the dampener, and hopefully that would absorb that amount. When you compare it to the Ford Cammer, the chains themselves connected to the cams and the crank, that is your vibration dampener. It's just like a guitar string. Okay, so any of the vibration coming out of the cams or the sprockets, and also from the rotating assembly of the crank, is transferred into the chain. Now, if you can imagine, if you've driven motorcycles that are chain driven for any length of time, the more slop that gets into the chain, the less durable it becomes and the higher percentage rate that they're going to break. Now, if you can imagine that with the Ford Cammer, yes, they would easily be able to flow as much air as the 426 Hemi within their designs, but they also had twice as much friction occurring between the cams and the cylinder heads. The chains were fairly, limited on how much friction they caused to the engine. So comparably, even though they were able to produce the same amount of horsepower, it was how much of the horsepower or torque produced is being absorbed within the valve train itself. So the camera engine being shrouded on one side of the valve, basically from the semi-Hemi design, just like the 429 Boss, and also the chain drive, it took more power to turn the engine. Now those chains being vibrated like a guitar string, they're gonna break. Now one of the things I can compare that to is the valve spring of any of your V8 style engines out there. When that valve spring starts to chatter as it is being compressed and released, the vibration in the valve spring also has to be absorbed within some kind of a dampening device. And normally that's the actual oil that's flowing over the valves. Some of the racers in the performance industry have realized that by shortening the valve springs or bringing them down to the point where at full lift, the spring itself actually makes a little bit of contact, it allows the spring to absorb some of that vibration. So what most of you have seen in recent history, within probably the last 2 years, is they've been talking about the binding points. Okay, most of you that are rebuilding engines in your yard or in your garage you're do-it-yourselfer, you're going to follow the instruction and the installation instruction for the valve spring height and so on and so forth. And even if you have cams that will lift, above 600 thousandths, the springs will be stretched out a little bit, not necessarily literally stretched out. They'll be taller to be able to handle that higher lift, or they will need to have the cylinder head clearance for the valve travel. The binding rate is when the actual coils of the springs get so close together that they will actually make contact. Now, if you have ever gotten the chance to put your hands on the 426 Hemi pushrod engine used by NASCAR, they used very short springs. They also used dampeners within the spring design. They didn't use a single coil valve spring. It was normally a triple spring. Each one of those springs becomes its own dampener. And the closer they get together to making contact, within realization, they would actually help the individual coils above it and below it to stabilize themselves at extremely high RPM. If there's too much contact, it's no different than the most modern day torpedo bats that are being used in Major League Baseball, hitting a ball that's traveling 105 miles an hour. Okay, they're going to collide and they're going to cause a disturbance within the material, and that's where valve springs normally fail. It's either by the uncontrolled spring compression or movement as the valve is being actuated, or to the point where they actually make contact. But to maximize performance, the springs have to be able to absorb as much of that vibration as possible. Now, that vibration is transferred into the rocker. So while many of you are using different aftermarket rocker systems, which one of the designs absorbs the most amount of vibration between the moving components? Over the roller of the rocker tip itself, through the material or the metallurgy of the rocker, and how it's attached to the cylinder head, whether that's through a rocker shaft, or if it's a ball and stud type design. Now, if you go back to, again, our discussion about the cammer also used roller designs and stamped steel rockers to actuate the valves. That material was submerged normally in oil within the cylinder head and within the lifter absorber itself. So the dampening did occur between both. But the amount of vibration from all the moving components of the Ford camera engine would cause the actual chains to absorb some of that vibration, and as they were rotating it around, they would break. Now, the difference between the NASCAR and the drag racing engines, again, they're both capable of producing the same amount of power. But the difference in drag racing is that amount of pressure is occurred during a very short time, whether it be 8 seconds or less. Those engines are revved up, brought up in the RPM range as the clutches engage, and the actual clutch material helps to absorb, the transmission helps to absorb some of the vibration from the rotating assembly and the rest of the engine. But at the front of the engine, the chains on the camber will not have the same frequencies or the same vibration exposure as the back of the engine. Where the 426 Hemi, between the front of the engine and the back, no matter what the transmission is, whether it be an automatic or manual, it's more equally comparable within vibration dampening. Now, another thing that has been proven with extremely high horsepower combinations for drag racing is the addition of superchargers. At that point, the actual belt of the supercharger system, the rubber belt, becomes an assistant to the vibration dampening. When equipped on a Ford camera engine, even though the rubber belt is there, the vibration from the valve train and the rotating mass of the crank is still exposed to the chain. The chain receives the same amount of vibration and harmonics. So while we never really got to see a hardcore Ford camera engine in NASCAR, because of the design, I do not believe they would have lasted as long as the 426 pushrod engines did. Now, again, that includes the other pushrod variants, including the 429 Boss, the Porcupine Big Block Chevy, to the Big Block Chryslers, all the engines used during NASCAR of that era. There wasn't enough introduction of the Ford Camry used in long-term racing to determine if it can withstand the same amount of abuse as the 426 Hemi. The 426 Hemi is still in use today within Top Fuel. There possibly could be some, vintage racers that have their hands on an original Camry engine within nitro fuel. But again, the fuel, the engine's being built around the fuel, the ignition and pressure that's being placed on the piston, creating the vibration into the chains is not consistent. It's very strong with every impulse of the piston traveling down. Now, depending on where that chain is within the sprockets, as that pressure increases, it's pulling on the chain. And as it goes around these sprockets, turning the cams, it's exposed to a lesser amount until the next cylinder goes off. So not only are they experiencing the same vibration as a pushrod engine through the valve train and through the rotating assembly, they're also exposed more to the chains of the entire system, being multiplied by the number of cams and also being connected to the crank. Okay, so for those of you that might know me a little bit, I can't stand Ford, okay? But I can respect the performance engines from no matter what manufacturer it is. Now, there was other Hemi engines created in that era of the muscle car. Oldsmobile, so on and so forth, they all created their very own variation. Even the ball stud Hemi that didn't use a chain, they used a belt. Okay, so Chrysler knew very early on if they were going to create an overhead cam design, in order to drive them, they needed to use a harmonic balancer within the rotating mass of the valve train. There's one copy, you'll have to excuse me, I can't remember. It is a dual overhead cam Hemi design that is also belt driven. I believe there's only two in existence. One is a museum in a cutaway variation, and I believe one ended up being put into a manufacturer only Barracuda. There's multiple Hemi ball stud designs out there that are using the rubber drive. Now, that was back in the 1960s, late 1960s, early 1970s. What have our foreign competitors learned through all of that? Almost unanimously across the performance industry, even if you start getting into foreign manufacturers, they are using the rubber belt drive type system. The ones that have gone to chain, including more modern American manufactured engines, such as the Coyotes or the Ford Mustang type engines, they're going back to the chain. Why? Okay. The rubber belts have proven to withstand the test of time. While the Camry engine was a very successful engine, there's no proof that it could stand the test of time. And even more modern engines, like the Crown Victoria Fords with the 4.6, are they getting high mileage? Are they getting 350 or 500,000 miles off of those engine combinations before the things blow? Any of the foreign manufacturers that are using chains with a chain dampener built into the valve train system, those ramps or those materials to dampen some of the vibration coming from the chains, the engine fails when those simple pieces of plastic or Kevlar devices start to fail and the chains stretch out, introducing slop into the entire system. That's when those engines fail. They have tried to address that issue with lightening up the entire rotating assembly. Even the Chevy pushrod LS engines, compared to the mod motors, their crankshafts have been narrowed, the crank throws have been narrowed. Everything is being pushed together to create a smaller package. That only changes the tone of the frequency of the vibration. That's it. Now, in order to address the chain stretch or vibration issue, they've added in the tensioners within the engine designs. But you don't need those tensioners, those ramps, those slides for the chain when a rubber belt is used. Just similar to like the root style supercharger, they have a tensioner to keep the belt in place as a guide. But if you ever see a high RPM supercharged engine, you'll notice that the belt is vibrating like crazy. It is absorbing the vibration from the entire system, along with the vibration dampeners of the harmonic dampener and also the transmission that's behind the engine. Okay, realize that if you have an automatic transmission that uses a torque converter, the fluid in the transmission system itself helps dampen the vibration. So if you're seriously thinking about the most amount of dependency on an engine for high mileage and high performance or high RPM sustainability, are you going to choose the 426 Hemi push rod style V8 engines, or are you going to choose the chain or metal chain driven Ford Cammer or modern day mod engines to do so? This is one of the reasons why I can't stand Ford. Okay, when you are an individual that either works on the equipment or has to do the machine work, you realize the more modern day those vehicles have and the changing materials that they're used in the engines, some of the worst engines out there are the aluminum headed mod motors created by Ford. While they have the chain dampening devices included, the vibration in the valve train between the cams and the cylinder heads, that vibration has no place to go. It goes directly into the cylinder head. And unless there's adequate oil to absorb the impact between the cams and the cylinder head itself, it's immediate catastrophe. With today's engine oils being reduced to viscosity and lacking some of the ingredients of older oils, there's less protection no matter what the chemical makeup or the detergent additives are. The small molecules in modern day engines, they're made for much more precise and closer tolerances in order to absorb some of that impact. The older engines with a wider circumference within their machining practices, that oil becomes the adding factor of vibration. So with that, hopefully that's kind of addressed some of the issues with the debate between the 426 Hemi and the Cammer. I personally would always choose the pushrod engines just because of the failure rate of the earlier chain-driven designs. Have a good one.